Have you ever wondered how scientists can be so sure about their findings, or how market researchers predict trends with such accuracy? The answer lies in a process called hypothesis testing. Hypothesis testing, in essence, is a systematic way to test claims or ideas about a group or population. It's a core component of statistics and the backbone of scientific research. But don't worry, it's not as complicated as it sounds. First, we start with the null hypothesis. This is a statement that assumes no effect or relationship in the population. It's like saying, nothing new to see here, folks. The null hypothesis is the one we aim to challenge and possibly reject. Then we have the alternative hypothesis. This is the statement that we want to provide evidence for. It's basically the opposite of the null hypothesis. It's saying, hey, there might be something interesting going on here. The next step involves selecting a significance level, often denoted by alpha. This is a threshold that determines when we reject the null hypothesis. Commonly, an alpha level of 0.05 is used, which means there is a 5% risk of deciding that an effect exists when it does not. Now we move on to the data collection and computations phase. This involves gathering the necessary data and calculating the test statistic. This statistic is a measure of how much the sample data deviates from what would be expected under the null hypothesis. Once we have our test statistic, we compare it to the critical value. The critical value is a threshold to which the test statistic is compared to decide whether or not the null hypothesis is rejected. If our test statistic is more extreme than the critical value, we reject the null hypothesis in favor of the alternative. After this, we interpret the results. If we reject the null hypothesis, we're saying that our sample provides enough evidence to conclude that the effect or relationship exists in the population. If we fail to reject the null hypothesis, we're saying that our sample does not provide enough evidence to conclude that the effect or relationship exists. So, to summarize, hypothesis testing involves: hypothesis testing is a robust tool in the arsenal of statisticians and researchers. It allows us to make informed decisions and conclusions about populations based on sample data. But remember, a hypothesis test does not prove anything definitively. It merely provides evidence for or against a claim. By understanding hypothesis testing, we can better comprehend the statistical information presented to us in various fields, from scientific research to market trends, and even in our daily lives. So, the next time you hear a claim about a large group or population, you'll know the steps that professionals take to test that assertion. You'll understand the process behind the claim, and you'll be able to evaluate the evidence for yourself. And that, my friends, is the power of understanding hypothesis testing.